Hello, everyone. So, welcome to the second episode of the Future is Robot podcast. I'm your host, Chandran, and today we are joined by Daniel, who is the
Hello.
director of Genie Robotics, which is regarding additive manufacturing. And to all those of you who are interested in the future of how exactly the manufacturing space is going to go about and how robots actually will play or are currently playing, as you might get to know it over the course of this podcast, uh, what role they play in this form of manufacturing in the future of how exactly this entire process goes. It's going to be an extremely interesting conversation. So, hi, Daniel. Thank you for joining me
Hi.
today.
Thank you for inviting me.
Yeah. So, Daniel, as we get started, like what was your initial reason for getting into robotics, like from your childhood or with respect to university and everything? What was your initial attraction or pull towards robotics and additive manufacturing as such?
Yeah, I don't know whether it's so easy to say. I've always been very interested in robotics and technology of all kinds. I mean, my father is an engineer and my mother is an artist, so I grew up between the workshop in the basement and the studio in the below the roof. Um, yeah, and so I've always had a lot of different inputs from as well the technology side as also as the creative side. And yeah, I've been uh, not working but playing with stuff like Fisher Technique when I was a kid. I don't know whether that's still a thing or around, that you could assemble like mechanics with plastic parts, modular
Mhm.
plastic parts. With it and construct complex machines with it. And that was quite fun while I was a kid and so on. And yeah, I can remember one scene when I was little. I always used to ask my father, "Daddy, what material is this? What material is this?" And for everything, I asked him which material it is. And after I've learned which woods there are, which metals there are, he told me that everything else is probably plastic. And I was really thrilled as a kid that so many things can be made of one class of material. And I think that was one of the foundations that later got me into 3D printing with polymers. And yeah, what really got me interested in 3D printing was I can exactly remember the first time I saw a 3D printer that was on a business fair in Munich where I used to live. And that was in 2007. And the thing it created was like an architectural model of a house shaped as a hand, which was cut out on the inside, and you could look inside and see people standing there. And it was a really intricate model. And I immediately knew that this manufacturing technology has the potential to change the world because you can make a lot of things out of it. Not everything, but a lot of things can be done made with 3D printers. And the point is that it's more or less location independent. So you don't need a big factory, or so you don't even have to be at the same place, at the same location where your engineer or designer is living. Everything can be done online nowadays, and you can download a 3D model from the internet and print it yourself or get it printed from a nearby uh, service, 3D printing service, and then you can create almost anything you can imagine yourself. And I immediately realized this potential back then when I saw the first 3D printer. And since then, I've read everything I could read about 3D printers. I got 3D printers myself years later, and yeah, I've been working with them since more than 8 years now, I think. Yeah, sort of. And I got the cheapest 3D printers that I could find on the market, and they had like every single 3D printing error you can imagine. And I've learned to cope with them all now. So that was a good place to start actually learn how to cope with the possible failures at least. And yeah, so that's how I got in touch with 3D printing.
Yeah, I mean, one of the things which I found extremely fascinating is you mentioned that the first 3D printer which you came across was way back in 2007. So, I mean, I do have a mechanical engineering undergrad, but I didn't really venture much into the field of additive manufacturing while I was studying. So, could you just tell about the history as such? Like, when were the major breakthroughs in the field actually started or with respect to additive manufacturing?
Yeah, the first 3D printers have been developed in the early 80s, I think, by 3D Systems, if I'm not wrong. And they're still around, still one of the biggest 3D printing companies. And about 20 years later, around 2003, 2005 or so, their patents ran out. And then Professor Adrian Boyer, together with his back then student Joseph Prusha, if I'm not wrong, have developed the first FDM printer as we know it today, which gave a huge boost to the technology because they open sourced this design. And Prusha nowadays is one of the biggest FDM printer manufacturers and one of the most advanced ones. So if you want to get a 3D printer, Prusa would be a good one to start with, I think. Although it's a bit more expensive than the Prusa clones. And yeah, other types of 3D printing technology are the resin-based ones, like the SLA printers that 3D Systems have developed, and their cheaper brothers, DLP or MSLA printers, which also work with resin but not with lasers. They use UV light arrays, diode arrays and display. And the display gets transparent or visible depending on the slice of the layer where it is, and it only shows it's only transparent where the light should pass through, so where the materials should solidify. And yeah, that's much cheaper to realize than with an expensive laser-based system. And then we have a whole array of different 3D printing additive manufacturing techniques for handling metals, like also laser-based machines where you have a powder bed where a laser comes from above and scans the slice of the object and melts the metal powders so that it solidifies. Other approaches for using metal are like, for example, binder jetting, where binder material is jetted on a substrate, or maybe also the metal is inside of a binder. Like you can even make the 3D printing with FDM printers when you have metal filament, which has up to 90% metal compound, and besides there's mostly PLA plastic inside, so you can use this metal filament on any cheap 3D printer to produce metal parts with it, and that works pretty well. But the accuracy is not that as high as when you're using a laser-based system or another one. For example, we have also electron beam melting. Also, there's a half a dozen or up to a dozen different technologies to work with metal, and well, most of them use metal powders. Some of them use metal wires that get molten by either a laser beam or by like the Vader machine by strong magnetic fields, which cause induction heating, and at the same time jet the material to the printing platform. And yeah, so that's a short overview of 3D printing technology. It's a whole field of study. There are nowadays the first classes, courses on universities for additive manufacturing that just came up during the last few years, I think. And yeah, I was also astonished that it took so long, since I've known this technology since 2007. Others have worked with it before. So this is we're quite at the beginning of development of this technology, and I think it has a great future. There's a lot of things we can still develop, we can still do. Yeah.
Yeah, I mean, uh, as you mentioned, with respect to additive manufacturing, it's still seen as one of those fields which is relatively new, because back in my undergrad, when I was doing in mechanical engineering, we were still doing either the conventional forms of manufacturing and machining, the typical casting, forming processes, we were studying about those. Or even if we were actually moving to more modern forms of manufacturing, it was usually the non-traditional machining, like laser beam machining or electron beam based machining, and so on. But additive manufacturing as such, even though we did have a couple of courses related to it, it was still seen as this pioneer or something which was pretty new. But knowing that this technology has existed from the 1980s and it continues to go on, I mean, it's just fascinating. It's probably just a huge lag between where the education system is right now and what is actually being implemented, which is causing this, apparent delay between the knowledge transfer, which should be happening. But yeah, it's nice that at least now, we are getting closer and getting in touch with this entire field of additive manufacturing.
Yeah, that's exactly what I mean. I mean, the technology now is 40 years old, and half of the time it's been restricted by patents. And even since these patents have been released, it has been now 20 years or so. And especially the academics are pretty slow to adapt this. I mean, except a few exceptions like Professor Boyer, there are hardly enough offers for additive manufacturing schools or universities regarding the potentially huge demand of the industry and of the private sector, which is maybe even bigger. Yeah, so we definitely have to work on that.
Yeah. Well, what do you think are probably some of the reasons why, why the academia is pretty slow to adopt this? Maybe it is actually being implemented in some parts of the world, but definitely not in all. So, what do you think is the major pushback which we are facing with respect to adopting or promoting this form of knowledge transfer in other places?
I have to object that it's not in every place. I mean, I've seen people from Africa, from India, from China. It's really big in 3D printing, and Latin America too. And I mean, they are making print shops in Africa. I don't know where it was, where I've seen the last one. I think it was Rwanda also. Or Kenya, they're making print shops and supplying their local community with things they need, which would otherwise have to be manufactured somewhere else, shipped around all the world, and so on. And that's I think why 3D printing has a huge potential, because you can democratize manufacturing, you can make distributed manufacturing, you can enable people to manufacture who did not have the possibility, the opportunity, the access to manufacturing equipment before, because 3D printers are fairly cheap manufacturing machines, and they're pretty easy to assemble, but not so easy to operate depending on their quality. But yeah, that's the point. Because of this technology being so simple, it can easily be adapted anywhere. Um, Yeah, and that's one point where I had to object to. What was your question again, please? I'm sorry.
Yeah. So I mean, yeah, I completely agree and understand with your point. But why do you think that the adoption of this, as you had mentioned, it apart from apart from some professors, uh, most of it is still facing some form of, I wouldn't call it pushback, maybe I would still say some form of passive resistance against its implementation?
Yes, I think it's hard to describe. Being a German, I can tell you that in Germany, new technologies in general are rather slowly being adapted, but once they get adapted, they're pretty fast to develop it to a high level there. But as long as it's new, many people object it because they're like they prefer what they already know. When it's new, they might not fully understand it yet, and they might see their way of living, way of working that they've practiced until now in danger because, yeah, maybe because of it enabling everyone to manufacture because that's for manufacturing companies, of course, if they don't adapt to the technology, it may be a threat to their business model. And you also may have issues with intellectual properties, like securing your IP, your design. If anybody could print it, then how would you control it? How would you monetize your idea if you don't cannot control which person is going to print it, whether he is or she has paid for it or not. That's, I think, one major drawback. And yeah, the other thing is that, how to say it, not everything can be produced by 3D printing, and the technology, depending on the material you use, depending on the machine you have, may have its downsides. For example, even if you make just plastic parts, simple plastic parts, these you always have to, because it's additive, it's layer by layer. Layer gets glued onto each layer below it. Every uh, place of the where the layers meet may be a possible breaking line where the material where the object breaks and fails, and that makes it difficult to use for many possible use cases. For example, in aviation, I would not use any 3D printed plastic parts in uh, places where human lives depend on. And even metal printed parts, they have little crevices and so on. It's like welding, depending on the technology. So you always have little bubbles inside of the molten metal and so on. So 3D printed part probably is not as strong as a part that has been milled out of a molten how's it called, cast iron block or so. So that's one other point that the print result has to be well, the application has to be so that it allows for 3D printing. That is, there shouldn't be too strong forces working on the part and so on. And it definitely should not be anything where human lives may be in danger when in case it fails.
Yeah, okay. And that's those are some amazing points as such. That actually makes quite a lot of sense. Even I'd recently read about the idea of, how, as you mentioned, as they are all glued on top of each other, shear forces can actually, cause issues, especially with respect to the plastic parts as well.
Yeah.
Uh, yeah, so I mean that is probably the best comprehensive overview of, additive manufacturing and its probable obstacles for its complete adoption.
And
So moving,
one more obstacle is that 3D printing is an awfully slow process. Um, because most 3D printing processes require material to get molten, and this takes time depending on the material, depending on the technology you use to melt it. It might be faster or slower, but you still have to build it up layer by layer. Newer approaches go a different way and enable for very fast modeling of at least tiny parts from resin. This is very, I hope this will get more developed, but for now, it's an awfully slow process. I mean, prints that take a few days are pretty common, and while you're printing a 3-day print, of course, you should have a good power supply. I mean, I'm living in an area where every now and then there's a power outage. I cannot make 3-day prints because maybe it fails on the third day, and I would have wasted a lot of material and time. And that applies for many places. And also the speed hinders us from widely adapting this technology for serial production, for example, because there's, I can send you the images later on, maybe. I have some graphs showing it, that the cost of, per part, the more parts you produce, you manufacture, with common technologies like milling, forming, casting, and so on, the more parts you produce, the cheaper it gets per part. The cost per part gets lower with the growing amount of parts. That is because you have to, yeah, it's complicated. Let's keep it like that. And with 3D printing, you have quite a linear advance of cost per part. So that means that the more you print, it hardly gets more expensive per part. You may have some additional cost over the whole batch for the maintenance, for the operator, for yeah, of course the material, but it's linear. But yeah, that's the point. Because of it being a linear curve and the other ones being asymptotic, I think is the English word. These conventional technologies at some point cross the line of the cost per part for 3D printing, and then it's cheaper to use the conventional techniques for larger batches than to use 3D printing for serial production. One thing that the conventional technologies cannot do is mass customization. That is, that every customer could get his part in his own color or with another add-on or whatsoever. That's possible with 3D printing, but still you have the linear advance of costs per part. And yeah, that's one reason, one other reason why 3D printing is not yet widely adapted in the industry, for at least not for mass producing items.
Okay, yeah, I mean that makes intuitive sense. So the more customized, the more specific a product is, additive manufacturing would still have the upper hand because it can produce it for a lower cost. But if we were to do large scale manufacturing, then conventional or simpler forms of manufacturing, as you mentioned, since the economies at scale would actually favor it, would actually make it cheaper. That's pretty interesting.
Mm-hmm.
So where do robotics as such come into this entire field of additive manufacturing? Like how did the robotics combine with the field of additive manufacturing, and what is the result which we get because of that?
Yeah, one thing is that in my point of view, 3D printers are manufacturing robots. I know it's not the definition, the precise definition of a robotic system, which would have sensors and think by itself to make decisions based on its environment and so on. But for now, most of the 3D printers are stupid machines, but we are going into this direction of 3D printing becoming more robotic, in the sense of being 3D printers being equipped with sensors in order to, for example, detect print failures while they're happening, or maybe even before they are happening, because you can, like that's what we are planning to do at the printers we're going to build. We will equip them with sensors and collect massive data based on the sensor inputs from all the printers we've sold. We will have sold, and based on this anonymized data, we will make analysis to see in which cases did a print fail. We will analyze how this defect occurred, which environment variables had which values, and so on. And then we can write programs like an AI or neural network or so to recognize these parameters and to monitor them, and then to predict based on these parameters whether a print is going to fail or not. And based on this prediction, to change the parameters in order to make sure that the 3D print will succeed and not fail.
Okay.
That's one point. Another point, excuse me, another point is that's already been done a few years ago. Imagine you have a 3D printer service point where a range of 3D printers is in a rack, and you have like a robot taking off the finished prints and preparing the next one. That's already being realized, and that can actually be combined with what I've mentioned before. And yeah, so these are the two possible ways I can imagine of 3D printing, additive manufacturing, and robotics getting closer together.
Okay. All right. So one is during production and one is post-production. So with respect to during production itself, you said that one of the best ways is actually to use artificial intelligence and neural networks to predict the failure of a print. So how often does that happen? Like on a rough estimate, how often and how much savings could a firm or a person or whoever is the user of a 3D printer have by the application of such sensors and neural networks in the process?
That strongly depends on the machine you have, I think, on the quality of the machine you have. Yeah, the quality of the build platform, the rigidity of the frame. There's a lot of factors based on the 3D printer model you have that can manipulate the print's outcome, whether it's just little defects in the print quality, like so-called ghosting, where you can see like little ripples behind the corners that come from vibration, from not very stiff frame, or from acceleration values also not being set correctly, until the whole print getting loose from the print plate because of not enough bad adhesion, or the print can, I mean, take a look at it also depends on the material you use. For example, ABS plastics are known for heavy warping by temperature differences. The material gets ejected hot, extruded hot, and then it cools down. And while it cools down, it shrinks a little bit, about 2 or 3%, I think, in the case of ABS. And because of the temperature gradient in the print, you have internal stresses in the printed part, which can lead to warping. It's called, where the printed part gets warped up at the corner, and hence loses bad adhesion, and this can lead to the whole print failing, because that's where the failure begins, and it pulls through the whole print, and at the end the whole print is going to be dragged around by the print head on the heat pad. This can happen, or yeah, defects in layer adhesion and interlayer adhesion. I forgot the word now. How is it called? This? I forgot it. I don't know anymore. Where the case is that the parts where it's glued together, they laminate. layer delamination, that's the word I've been looking for. Yeah, this can be caused by the internal stresses caused by the temperature gradients and so on. This can be easily fixed by putting your printer inside of a cabinet so that the printer's environment, the air inside the cabinet can be controlled. And this is also necessary for printing higher grade engineering plastics like PEEK or so, because they need a high temperature and a constant environment temperature in order not to deform and so on. And yeah, that's one point. What was your question again?
Yeah, no, it was with respect to this itself, about how exactly this concept of additive manufacturing as such is affected by, the various applications of robotics as such. And as you mentioned, using neural networks, we're able to actually predict and probably build adaptive models so that it can help save the print failure, prevent print failure, and probably lead to reduction in costs as well.
Yeah, we also have one category of 3D printers. It's called robotic 3D printing, actually, where you have the print head mounted on a robotic arm, like a 5 or 6 axis system or so. And the better these get, the better this technology would also get. And I think that this technology also has a great potential because, as you know, from the 3D printing, not the 3D printing, the robotic arms we currently have, like ABS or KUKA systems or so. They're like in every big factory, and they can make a whole array of possible tasks. So I've already seen like big robotic arms like these at the Fraunhofer Institute in Aachen, where they have put a laser at the tip and how is it called? ELH, I think. I don't know anymore. EHLA. Also technology where there's a laser beam and there's a nozzle around this laser beam where metal powder gets blown into the laser beam, and thus can be applied to material or object, and you can create whole 3D printed objects with this. And they have used it with such big robotic arms. And yeah, that's one point where I think that the robotics can be a great influence to additive manufacturing, especially once I mean, these big ABB or KUKA robots, they're big and expensive, and for 3D printing, they're pretty much overkill, if you're asking me, at least for the for makers also, or for people who want to 3D print at their homes also, or small businesses. They won't buy I don't know how many $1 million robot, but when we can produce such robots in a smaller scale that have high accuracy, high repeatability, and come at a low cost, then this technology will be a major driving force for the 3D printing, I think, especially since you can make tool changes and so on, and also add a milling tool or whatever to this thing. And depending on the amount of the DOFs, the degrees of freedom you have in this robotic arm, you probably will be able or are able to rotate the tool and to not only print in the X Y plane, but you will be able to print in any spatial direction. So you will need less support materials, which greatly enhances the printing speed and reduces the material you need and gives a smoother shape outcome at the end, because you don't have any stains of the support. You will need to make less post-treatment for such printed parts. And the better small robotic arms become, the more of these type of 3D printers we will see, I think.
Yeah, I mean, that's actually fascinating. So instead of being layer by layer by layer, we could actually just, or put it at any particular angle, achieving more, precise designs and with lesser failure, because then shear itself would not be limited to one directional, but it could be
Exactly,
spread
yeah.
across multiple directions, making the entire process safer. That's actually extremely interesting. The idea of, using robotic arms with greater degrees of freedom to achieve more specific points as we move forward.
Mhm.
Yeah, that's. I actually did not really consider that before. That's actually a very interesting idea. Hmm.
Yeah, it's mostly a slicer problem, a software problem nowadays, because we actually have such 3D printers already. They're not very widely spread. I don't know why, but I think it's mostly a slicer problem because most slicers, most open source slicers, at least, are focusing on this two-dimensional or 2.5 dimensional 3D printing, which it actually is. And this real 3D printing, where you can move the printed in any direction and so on, that's not widely accepted, not widely realized by the software producers who write this software you need to get the G code to run the 3D printer.
Yeah, I mean that's an interesting discussion. The idea of that and how exactly it is still it's currently growing as such, and how eventually it could possibly be quite mainstream with respect to 3D printing. So yeah, now we've had like a huge discussion from the technology point of view, but you're also the director of Genie Robotics, and I'd love to actually hear your, take from the business aspect of robotics, and as a company which is based on so much so much technology and cutting edge technology, which is extremely relevant in today's world. So, what do you think are some of the biggest business challenges and problems and various obstacles that you've encountered
I
from the
can
business side?
tell you. Yeah, the biggest obstacle we currently have is that we don't have a finished product yet. It's still in development, and we need funds in order to produce the prototype, which I'm currently working on. And I have to work on side jobs like web development jobs and so on in order to get some money that I can put into the 3D printer. I mean, we're a lean startup. I'm not going to the hairdresser anymore. You can see I'm putting all my money into the 3D printing business I'm building. And yeah, the challenge is to get these funds, because once you get go to investors or to the bank or to a pitch for whomsoever, one of the main questions they're going to ask you is, do you already have a prototype? And I'm like, no, I don't have a prototype because I need investment to build the prototype. And they say, yeah, without a prototype, you won't get any investment. And that's a huge problem, I think. Yeah. So now I'm bootstrapping it with my own little web development income and so on. And that's a huge challenge, because I not only don't have a lot of money, but also I don't have a lot of time, because I have to split my time between the job for the money and the development of the printer, of the company, of the pitch deck, whatsoever, of the various components of the 3D printer we are developing new, and that takes a lot of time. And that's a huge problem, the time management and the money and getting funds for a project, for a product that doesn't exist yet. Everyone wants to see a prototype first.
I think that's really inspiring. Most people would probably just not even if they were actually to be met with such a obstacle, it probably wouldn't. They would probably just not have the resilience to go ahead with it. And I honestly must say that's extremely inspiring that you are still moving
Thank you.
forward and bootstrapping this entire venture as such. So, with respect to Genie Robotics, how did the idea come about? What is your inherent passion and your reason for going behind it?
Yeah, I've wanted to make my own company since a long time, and especially to make something with 3D printers. And the big thing, which I've already mentioned before, is that 3D printing is an awfully slow process. I mean, you can fall asleep while waiting for a print to get finished and so on. I've seen people at the universities fab lab sleeping beside their 3D
Yeah.
printer running. And that's really the biggest negative aspect of 3D printing nowadays. You can ask anyone who has already made a 3D print, they will all tell you that the printing speed is a problem. And yeah, that's a problem that Genie Robotics is working on with our new 3D printer. We have identified that the 3D printing speed is the problem that every user has, every user of 3D printing has, and we have identified the four main causes for this slow speed, which is slow motors that aren't very precise, then that the material has to be heated, and depending on the material you're using, that takes more or less time. And yeah, in between times, print cycling times, like heat cycling times, you have to wait until the heat platform has cooled down so that you can remove the part, and then you have to wait until the heat platform has heated up again so that you can print the next part, or you have a magnetic plate where you can take out the part on the magnetic platform and just put in the next platform to start the next print. But this also needs human or robotic intervention. And the fourth point was, I forgot. Wait, the motors, the materials, what's the fourth point? Third point, fourth point. Yeah, I forgot. But wait a second, that's important. I'll have to look at my pitch deck for a second.
Yeah.
Wait a second. Where is it? That's a bit embarrassing, but I'm very forgettive. So please excuse me. That should be what I could. I really have to train or pitch more. Yeah, exactly. The nozzle, the nozzle size. You can either print with a small 3D printer nozzle and get a more detailed print, or you could use a bigger nozzle and extrude more plastic in the same time. Through a bigger nozzle, but then you lose the accuracy in the finished part. You cannot produce such intricate details like with a 0.2 or 0.4 nozzles with a 0.8 or even 1 millimeter nozzle or even taller. You will be able to print much faster with it, but you're definitely going to lose the details. So depending on what you're working on, a larger nozzle might be a good solution because maybe you don't need that much detail at all. But if you want to have a machine that's able to produce fast parts as well as detailed parts, then you would always have to switch the nozzle or use a multi print head machine or so, dual extruder machine or something like that. Yeah, and these four problems, the motors, the material, the nozzle size, and the part removal are going to be fixed by the machine we are working on. We are working on four innovations, more or less innovations. Some of these aspects have already shown up on the market, but we are the first company to produce a 3D printer that incorporates all the solutions for these four causes of 3D printing being so slow in the same machine. So we will be able to produce a machine that will be multitudes faster than conventional 3D printers, and this will cut down the cost per part, so that the 3D printing will be more competitive for producing large batches of parts, which may be individualized too, than it was before. So with our machines, manufacturing company or manufacturer will be able to produce more parts at a lower cost in less time than with conventional 3D printers, which causes the point where these graphs that I've mentioned before have their meeting point, moving further to the right side, where the cost per part it's shown, it's growing towards. No, the amount of printed parts. That's the right axis. So you will be able to instead of first producing like a casting mode or so, you will be able to produce as many parts as with a casting mode with our 3D printer in less time with less effort.
Hmm. And how big of a time reduction will this be able to achieve?
That's for now purely theoretical, but the motors we are going to use will be able to probably go about 5 meters per second, and that compared to the usual printing speed of 60 to 300 millimeters per second, a huge increase.
Wow.
And yeah, and by the nozzle we are going to use, there will be also a factor of maybe times 3. So we are talking of multitudes faster. I cannot say how much precisely yet, because in order to be able to say that, I will need the prototype and run some tests on it. But theoretically, 10 to 250 times faster, depending on the machine you're comparing it with, and depending
Wow.
on how fast our system will finally be.
Wow. And which industries or which sectors do you feel this form of manufacturing would directly be applicable to and would directly, disrupt or help in the most?
Quite a lot directly. Our early adapters would probably be print services, print farms who are already running print service and who already have like 30 machines, 100 machines or so. We've talked to a lot of people like that, and they've all said that would be great to have such a machine. This market segment is very interested in our machine, and I think these will be the early adopters and our main customer segment. But we are also talking with companies like Arm Bionic, who are producing 3D printed prosthetics for war victims mostly. They're also very interested in such a machine. They could produce a prosthetic, robotic prosthetic with myoelectric sensors in like maybe 2 days instead of 2 weeks or so. So they could help a lot of people more in much less time. And the point is, this technology can be used in many, many, many industries. I mean, you could even make chocolate 3D printing, which actually is a thing. Also, and there's a whole lot of possible use cases, and they all would benefit from faster machines.
Wow. Okay, that's amazing, especially hearing about how, prosthetics, the product creation cycle can be reduced from weeks to days, can be truly, life-changing for multiple people out there. And I mean, that's extremely revolutionary. So, so how does your, like day go? Like I heard about what you mentioned with respect to the web development as the primary financial source or the financial funnel which goes from there into the additive manufacturing. But with respect to this idea and with the respect with realization, how does your typical day go, and what all work do you usually do with respect to that?
Yeah, I'm trying to split it like 50-50 or so. Maybe it's not 50-50 in the same day, but one day I'm focusing on this work and the other day I'm focusing on that work. But the plan is actually, yeah, to wake up, to work a bit on web development, for example, and a few hours and then a few hours on the 3D printers. Yeah, the work on the 3D printers itself. For now, I've been mostly setting up my own 3D printing studio here. I've got a resin printer there and two FDM printers behind the laptop. And these are very cheap machines and they needed a lot of setup work, calibration and replacement of uh, add-ons that I printed like 5 years ago in my old workshop, which got brittle and broke eventually. And yeah, then I'm also making CAD modeling of the printer prototype parts, of course. And then I also have to work on the pitch deck, on the business model, on the financial models, and so on. So that's a whole lot of work, and I'm always, yeah, if not trying to make it like block-wise inside one day, then I'm trying to focus on one task at a day so that I can really focus on one thing and don't have to switch every few hours. That's more efficient.
It seems like, completely packed days with quite a lot of work with respect to even the business side, with respect to the web development, with respect to the technology. I mean, and I'm guessing it must get sometimes pretty intense for you to manage everything at once.
Yes.
Okay. And also, how do you think, platforms like LinkedIn, we corresponded first on LinkedIn. So how do you think platforms like LinkedIn and, such forms of social media actually help either get your reach, maybe give you some new ideas, build connections, and so on?
I think that's nowadays the way marketing works, the probably best way marketing works. I mean, I have a certificate in social media marketing too. I have built a Facebook group with more than 2,300 members, I think nowadays, which is called. May I make advertising for it? It's called monetize 3D print. It's written in one word, facebook.com/groups/monetize 3D print. And there you can find my group. I haven't been very active in the last few months in this group because I've been focusing on the other work I've just mentioned. But I used to print to post um, like new development of the 3D printing market in this group every few days and so on. And yeah, I think especially LinkedIn, Facebook is more for like the B2C market because there's like the makers, the people who have just got a 3D printer for Christmas. Now you can see a lot of people like, hey, I'm new to 3D printing. How can I solve this problem and so on? And that's pretty nice to see. And even 10-year-old kids where their mom is asking how she can get help and so on. That's pretty funny. It will be great to see where these young people who are starting with this technology now will be in 10, 20 years. And there's a huge potential getting that free now. And yeah, LinkedIn is more for the business sector. You have, I have a huge list of companies I'm following or connects I have who are working on 3D printing already in companies. So this it is a technology that is currently getting more and more adapted by the industry, and more and more companies are switching to this type of manufacturing, at least for in-house prototyping, if not even for full-scale, yeah, end customer product.
Mhm. Okay. And as you mentioned, with respect to 10-year-old kids who have this technology. So in your view, with respect to additive manufacturing, robotics and everything, how do you think the next 10, 20 years, ideally at least in your view, or how you imagine it to be, how do you think it's going to unfold if this technology's potential is fully realized? both robotics, additive manufacturing, and the related fields of automation, artificial intelligence. As they come together, what is your ideal future or vision for what you think everything's going to look like?
Okay, if you want to see the big picture, then I have to make it a big picture,
Hmm.
then I have to go into a bit of theory of economics, which
Hmm.
I've learned at university 15 years ago while I studied politics, um, for a while at least. I didn't get the diploma, but that's another story. We have two major economic systems, not political systems, economic systems, which are called capitalism and communism in the last 150 years. And both of these systems share one big drawback, which is the misallocation of resources. Like in the Soviet Union and the communism, they first of all they made an analysis. They gathered information of what is needed, where is it needed. This maybe took 1 or 2 years until they had the whole list. Moscow needs hammers and Petersburg needs nails and so on. And until they, I mean, that was 100 years ago. You have to think about that. Nowadays, this would be made in an instant. That's where I'm going to come to. So they took 1 or 2 years for the information gathering. Then they took 1 or up to 3 years or so for the analysis and for making the plans. And then they made a 5-year plan, what to produce during the next 5 years, which was based on data from 5 years before. So the people who needed hammers now needed nails and got hammers, and those who needed nails before got the hammers. So it was misallocation of resources based on slow data treatment, analysis, and plan making, and so on. In capitalism, we have the same problem, but because of different reasons. In capitalism, you also have to make a market analysis first in order to know what does the customer want, what does your potential client need. I mean, we at Genie Robotics, we are a startup company. We are following the lean startup method. We've had dozens, if not hundreds, of interviews with people in the market working with 3D printers. And we ask them, what do you need? What are your problems? Which challenges are you facing in your work with 3D printers? And what would you expect from another 3D printer that you would buy? And that's how we identified this main problem of them being slow. So if you are an entrepreneur in capitalism, you have to make this market analysis. If you don't make this market analysis and just produce whatever you want to produce, you will have the same problem. Your product will go to the landfill. Nobody is going to buy it. So many companies just produce everything or anything just so that the machines are running, because it costs money if the machines are not running. They produce anything and hope they will be able to sell it and throw it on the market. And if nobody sells it, then they spend huge budgets on advertising. And this also creates a lot of waste, paper waste mostly. And yeah, that's still many things don't get bought and go to the landfill. So you have the same problem, misallocation of resources, not only of material resources, but also of work resources. That is yeah, making the, I mean, we've lost a lot of time for making the market research. We could have produced the printer 1 year ago or 2 years ago if we had known what the market needs and so on. But we had to make the market research first. That took a lot of time. So we used a lot of, not wasted, but used a lot of time resources, human resources on making this market research. If we cannot sell it, we will have to make advertising for it. We will have to put a lot of funding of human resources and so on into the marketing campaigns, which also wouldn't be needed if everybody would use the system I'm talking about now, which is like real-time planned economy, which you could call it. It's like the combination of communism and capitalism and with the real-time market analysis and so on. I mean, you can make, we have blockchain technology nowadays. That's an open ledger where everybody can make orders and get them fulfilled and so on. And that's actually something we're working on Genie, at Genie Robotics. Once our printers are produced, they will have a blockchain integrated, and the blockchain will be connected to an online market platform where designers can upload or even create their own models, and then they would be transferred, ordered by the customer and transferred directly to the next 3D printer. So we are going to produce an international manufacturing cloud, which will serve the society's demands, the needs for products in real time. We will in real time analyze what's needed by customer orders, and in the same second that a customer has ordered and paid a thing, it will get sent to the 3D printer, and it will be printed and high-speed printed, so quickly printed, and be sent to the customer. And yeah, this way we can eradicate the problem of misallocation of resources, at least a bit, because the 3D printer only produces what the customer has ordered. There are no orders, no parts being produced for a non-existing demand, and we know the demand because in real time, because yeah, when the customer needs something, you need a nut, you go to the website, you order a nut, and this way we can in real time analyze the demand, and then once it's running, it has been running for a while, we can make big data analysis on the demands and see which parts are probably going to be needed where. We can let a lot of market factors flow into this calculation. So imagine the pandemic, okay? During the pandemic, huge demand for 3D printed face shields has jumped up. A lot of 3D printing services started producing face shields that was just like a plastic strip that could easily be bound to your face with the place to hold a plastic sheet, transparent one. So imagine maybe not a pandemic, but a disease somewhere comes up, and then you can calculate based on the data of this disease that in this area some parts are going to be needed that can be 3D printed. So we would be able to automatically tell our manufacturing cloud to produce these items for this area and so on. So you can imagine that I don't know, there's a lot of potential events that could influence what's needed where, and so that could be used to influence the algorithms telling the printers what to print where. And that's, I think, an adaptive economic model that in real time adapts to the society's needs, produces what's needed and nothing more, and thus saves a lot of waste, saves a lot of resources, of capital, of material, of human resources, whatsoever, of fuel for transporting things that nobody wants to have. You know, we can drastically reduce our carbon footprint by massively adapting 3D printing technology all over the world and connecting this to a AI-driven backend.
I think this is I mean, this has to be one of the most, revealing discussions which I've had on this topic, because, I mean, for me, particularly the two main takeaways were especially how, you can use data, you can use as the world is changing at whatever rate, using the ability to analyze and understand what this data is representing and immediately mobilize action using technology like additive manufacturing, as you mentioned from your pandemic example, and also using decentralized technologies like whether it's blockchain or even additive manufacturing, 3D printing, which could be there in someone's home so that they can expedite the process by themselves. If this is there at scale, the efficiency, the way in which we function on a daily basis would be so free, would be so, truly liberating, one could say. in such a way that it would genuinely be free, what every economic model and what every political system actually says or wishes to achieve. But just, by the application of these forms of technology and these ideas that can actually become a realistic possibility moving forward into the future.
Exactly.
That's beautiful.
That's the democratization of the manufacturing technology of industry. I mean, large centralized industry has created a whole lot of problem from exploitation of labor to destruction of environment. And if we had more 3D printing based, or not only 3D printing based, but more decentralized manufacturing, where many people have their own small local businesses making manufacturing for the society around. I mean, imagine in the medieval ages before industrialization, like every little village had their own smith, had their own carpenter who produced whatever was needed by the village, for the village. And I want a 3D printer made by Genie Robotics in every little village all over the world, so that we can get back to this point where goods the local society needs are locally produced, ideally from locally reduced recycled plastic waste or so, so that we don't have a logistics chain that spans the whole planet, and as soon as one ship gets stuck in the Suez Channel, nothing works anymore. And the whole worldwide industry collapses. And for months, if not even a year, like I don't know how much time has passed, but I think we still have a bit of influence by the ship in the channel. For a long time, the whole globalized networked industry is like flat, like nothing. And I mean, in Europe, we have the energy crisis now. I don't want to talk about the political reasons, but we have this energy crisis now. And I mean, transporting things has become very expensive. And that's not necessary if you can produce what you want in your neighborhood. Everything you need is the raw material. The raw material can be sourced out of plastic bottles. That's one of my next projects, making a plastic recycling machine to recycle all the bottles I have from drinking lemonade and so on. And yeah, by adapting decentralized manufacturing, we can not only democratize the industry, but also reduce waste, reduce energy consumption and the waste of energy, which is not actually necessary. And we can save a lot of resources that will benefit the people who come after us.
Oh, yeah. Yeah, I mean, that just ties every single aspect of our discussion together. It brings about the entire point of the applications of this technology, how it can truly transform the world, and how it's not just limited to large scale applications or in the hands of technological giants or institutional giants, but just gives power to the common public. And I mean, that that is going to just disrupt the way in which we live our daily life once it has been completely realized. And I feel that that day when we wake up and we realize that this is a true possibility, that's then we're going to look back and realize that there is so much difference from how we used to live to how we are at that particular instance, that it's going to be difficult for people in from that particular point of view to even imagine existence as it is right now. That's amazing. That's
It
terrific.
will be a totally different world, yes.
Yeah. So yeah, I mean, Daniel, I guess it's time to probably just conclude. So I just wanted to ask you, and I'm sure the viewers would also love to know if you have any final thoughts, any final books, recommendations, resources, anything you like to leave with them, so that we could possibly learn more about the topic or anything as such with respect to your company, the ideas of automation, robotics, anything as such.
I haven't written my own book yet, unfortunately. I'm thinking about writing one with the help of ChatGPT, of course. Yeah, but one good point to start. Wait a second, I have it here. If you want to get into 3D printing, this is the 3D printing handbook by 3D Hub. It's a very well-written, comprehensive overview of the different technologies of 3D printing and how to work with them. And that's one of the best resources I have seen so far. And of course, most of the technology happens online. How could it be different? I think 3D printing industry is one blog, one magazine, which is very good. Yeah, I can write you a list of good resources for 3D printing information on 3D printing. And I also have to say that during the last 2-3 years, the number of publications on 3D printing I've seen has like exploded. Before you had like a few magazines writing on this, and now I can find it on big media outlets from the German press who would never have written about it a few years ago. Yeah. So by this, we can also see that it's a technology that's luckily, it's getting more and more adapted.
Yeah. I think that wraps up this entire episode. And I mean, it has been quite literally a journey from going to understanding the various issues with respect to additive manufacturing, what we're facing, and moving on to, its realization, what are some of the challenges, your entrepreneurial journey, the technology behind additive manufacturing, how robotics are involved. And then we even went into economics and policies and actually deciding how exactly all of it comes together to determine how technology and its access to the common public could truly change the way in which we live. I mean, this is an extremely inspiring conversation, Daniel. I mean, I cannot even put into words with respect to all of those ideas, whether it's with respect to writing your own book or creating a new machine which recycles with water bottles, even even your current idea of creating a 3D printer which can expedite processes which take weeks into days. It's been a really enlightening and inspiring journey. So thank you so much for agreeing to be on this podcast. It has been one hell of an experience.
Thank you too. Thank you for enabling it for me.
Yeah.
For inviting me.
Yeah. So thank you guys for tuning in to this particular episode of The Future is Robot. And yeah, the next episode will be put out in a couple of days as well. So do tune in. And thank you for joining us. See you guys.
Bye-bye.